Alright guys, today I want to also share with you a thought process which you can use on a halogenoalkane type of question. So for example, if they give you a organic question, right, with a attached graph, most likely it is a integrated question of kinetics with Rx. Okay, kinetics with Rx. This is a very common integrated question that they always like to put together. Okay, so for a student, right, what do we first have to do? We first have to assess whether is it SN1 or SN2 reaction before answering the rest of the question. How do you tell whether is it SN1 or SN2? If it's a primary halogenoalkane, likely it's a SN2. Okay, there is this exception which you have to keep in mind. Okay, there is if there's a CX group, right, halogenoalkane, right, your Cl is just beside the carbon which is bonded directly to the benzene ring, or the carbon which is directly bonded to alkenes, right? Whether is it benzene ring or alkenes, right? You need to consider the carbocation that can be formed will be resonance stabilized. So this will cause it to be SN1 preferred. In fact, a lot of times in exams, right, we are going to set questions with these kind of structures, all right, so that to check whether you understood. Okay, even though it's a primary Rx, it will undergo SN1. Okay, if it's a tertiary, likely to undergo SN1 because of the steric hindrance and a positive, very stabilized carbocation. Okay, so these are actually very clear-cut example, but if it was a secondary halogenoalkane, you have to look at the kinetics or the optical data, okay, in order to deduce whether is it SN1 or SN2. SN1, they will have a first order reaction graph and a show constant half-life. So anytime you have a graph, right, that you can get a constant half-life, or you can deduce that it's first order, you got to know that it is undergoing SN1. Okay, the optical data wise, they may give to you a observation of a racemic mixture, or they say is optically inactive product. Okay, because the nucleophile, according to the mechanism, right, it can attack from the carbocation from the top and bottom, so it will give you 50% of the two enantiomers. So this, right, you will also have to deduce that it is a SN1 mechanism. All right, so when you see a question, right, the first thing you see a graph, and then you see that there's a halogenoalkane, your thoughts have to be somewhere along these lines. All right, so that it allows you to process the question very quickly using some mental shortcuts, your heuristics. All this comes when you have practiced a lot. All right, so hopefully this helps. If it does, please remember to like and share this video with your friends, and remember, subscribe to the channel.